Suppose the limit as n approaches infinity of the absolute value of a sub n plus 1 divided by a sub n equals 1. Find the radius of convergence of the given power series. We have the sum from n equals 1 to infinity of a sub n times 4 to the power of n times x to the power of n. Notice here we're not given the formula for a sub n. Because we have x to the power of n, which we can think of as the nth power of x minus 0, the power series is centered at x equals 0. Referring to the notes on the right, the x values for which a power series converges is the interval of convergence. Since the series diverges for x values such that the absolute value of x minus c is greater than r, the length of the radius of convergence is 2r, and r is called the radius of convergence. If a series only converges at x equals c, r equals 0. If a series converges for all values of x, r equals infinity or r approaches infinity. Let's use the ratio test to determine the radius of convergence. Because a sub n is already being used as part of the formula, let's let b sub n be the given formula. And now to determine b sub n plus 1, we substitute n plus 1 for n. And now let's set up the limit. We have the limit as n approaches infinity of the absolute value of b sub n plus 1 divided by b sub n. And now let's begin to simplify. Focusing on the base of 4, we have 4 to the power of n plus 1 divided by 4 to the power of n, which simplifies to 1 factor of 4. Recall when dividing and the bases are the same, we subtract the exponents, and x to the power of n plus 1 divided by x to the power of n simplifies again to 1 factor of x. This indicates we can write the limit as n approaches infinity of the absolute value of the quotient of a sub n plus 1 and a sub n times 4 times the absolute value of x. We know the limit as n approaches infinity of the absolute value of the quotient of a sub n plus 1 and a sub n is equal to 1, and 4 and the absolute value of x are not affected by n, and therefore the limit is equal to 4 times the absolute value of x. If we wanted to, we could factor out the 4 times the absolute value of x and write it as 4 times the absolute value of x times the limit. Either way, the limit is equal to 4 times the absolute value of x, which we know by the ratio test, the limit value must be less than 1. This gives us the inequality 4 times the absolute value of x less than 1. To find the radius of convergence, we divide both sides by 4 and solve for the absolute value of x, giving us the absolute value of x is less than 1/4, and therefore the radius of convergence is 1/4. This also indicates the series diverges when the absolute value of x is greater than 1/4. So again, to answer the question, the radius of convergence is 1/4. If we did want to find the interval of convergence, we still don't know what's happening at x equals negative 1/4, as well as x equals positive 1/4. So we know the series converges on the open interval from negative 1/4 to positive 1/4. However, for the interval of convergence, we would need to test the endpoints of x equals negative 1/4 and x equals 1/4 and determine if the series converges or not at those values. I hope you found this helpful.